Welcome back to My Learnings channel. Today we are going to learn about Docker and its architecture, and then we'll have some demo. In that demo we are going to create a new container image, and we are going to bring up the new container using Docker CLI commands. Before we jump into today's our actual topic, let's recall what we learned in our previous session. We learned about virtualization process, and we did some comparison study between virtual machine and containers, and we identified that the maintenance, fault tolerance, and cost point of view, containers are better than virtual machines. Now let's stick to our actual topic, a software container. A software container is an individual package. All dependencies which are required for your software are within the container itself. In fact, all are bundled together. That's the reason it can move between environments. So once the developer is done with his coding, he can create a new container. At the same container, he can promote for the testing. And the tester, once done with his testing, he can promote the same container for production release. If you have a CI/CD pipeline for your application, Jenkins instance will take care of creating the new container and deploying it on UAT and then promoting it to production release. So before we go further in our topic, I want to explain a bit more about microservice and monolithic applications. Don't get confused with containers and microservices. Containerization is a purely deployment solution, and it can apply to both microservices and monolithic applications, where microservice and monolithic both are architectural styles and purely functional deliverable point of view and maintenance and some non-functional requirements like availability and optimal system resource utilization point of view. So let us stick to our topic. How to create a Docker container. So by using a open source Docker software, it's a containerization platform. It allows us to create a new container and run that container. Docker is written in Go programming language, and it takes the advantage of several kernel features like namespaces and C groups. Namespace provides the high security. Whenever a Docker brings up a container, it creates a set of namespaces. The Docker engine will take care of, in line with the right namespace, to access its limits. In the same way, C groups create the system resources into multiple groups. Whenever any task comes from Docker engine, it assigns to the right group. If you are targeting for a Docker administration side, and you better to explore more about namespaces and C groups. Now, the Docker engine. When we say the Docker engine, it's a combination of Docker daemon process and the Docker engine REST API and a Docker client. The Docker daemon is a background process, and it maintains the Docker images, containers, network, and storage volumes. And it constantly listens and report to receive the API request from the client. And Docker engine REST API, an API used by the applications to interact with the Docker daemon. And it can be accessed by an HTTP client as well. By Docker client, a command line interface, it communicates with the Docker daemon to get your job done. If you want to build a new container image and you have to trigger some command, and internally the Docker client communicates with the Docker daemon. Now let us deep dive into the Docker architecture. If you see the below diagram, in this diagram, the client communicates with the Docker host, and the Docker daemon instance communicates with the Docker registry. That registry can be a private container registry or a public Docker hub. And internally, Docker daemon maintains a local copy of images, the local registry, where the Docker daemon instance is running. And the Docker daemon will take care the responsibility of maintaining the container state and the images. If you are trying to bring up a new container based on the latest container image, then the Docker daemon will communicate with the respective registry based on your configuration, and it pulls the image and then it brings up. Docker client enables users to interact with the Docker daemon. A Docker client can communicate with more than one daemon, and it can connect to remote Docker instance as well. Here I have specified commonly used CLI commands: Docker build to build a new container image, Docker pull to pull the container image from private container registry or from public container registry, Docker run to bring up a new container in your Docker host machine, Docker images to list out the images which are available in your Docker host, and Docker RMI to remove the Docker image from your Docker host, Docker RM to remove the container which are running in Docker host. So now the Docker host, you can understand the Docker host this way: a host where you did the complete Docker setup. In other words, a complete environment where you can create and bring up a container. And it's a combination of Docker core background process instance, that is Docker daemon, and Docker network and storage options. Docker daemon process is responsible for all container related actions. And now let's discuss about primary Docker objects. Those are Docker image. A Docker image is a read-only binary file. It's a definition of a container. It contains your application and metadata about container. If you want to share the Docker container image which you created, you must keep your Docker image in a private container registry to access within your organization. When it comes to container, it's a isolated workspace. The Docker engine will take care of a container's health. Whatever it requires will be providing based on Docker container image. The container only have access to the resources that are defined in the image. To bring up a container, the primary input is container image. Now Docker networking. Docker networking is a big concept. We need an individual session to complete it end to end. But for now, I'm going to explain on a high level. By default, once you're done with the setup, Docker come up with 3 networks. One is none, host, and bridge networks. None and host both are part of Docker networking itself, because it doesn't require any network level isolation, where bridge network automatically creates and all containers that belongs to this network can talk to each other via IP addresses. Other than these 3 addresses, your administrator can create a user-defined networks. Those are bridge network, overlay network, and MAC address-based network. Bridge network is not a default bridge network which got created when you bring up the Docker container. This user-defined bridge network doesn't require any port forwarding, and the containers which are running on the same network can talk to each other with where overlay network to communicate the containers which are running on different hosts. So now let's jump into the storage options. Because containers are by default stateless, which means once you restart the container, all your application logs will get deleted automatically. So it doesn't store your application logs in your secondary disk once the container brings down. So you need some volume mounting to store your application logs or whatever the information which got generated at runtime or the application working time. So Docker offers 4 options: data volumes, the data volume container, directory mounts, and storage plugins. There are storage plugins from various companies to automate the storage provisioning process. Now let's start the actual demo. In the demo, we are going to create a new container image and we are going to bring up that container. If you really like this video, please like and subscribe.